Hello, everyone. Today we have a very nice, challenging question for you to give a go. So, can you pause the video, do part one, and then especially I would like you to do part two. For part one, what you would do normally is to write the reactants. So you have platinum, hydrochloric acid, nitric acid, and then you write your products, which is going to be this hexachloroplatinic acid. Wow, super acid. And you also have nitrogen dioxide, you write it there. Perfect. So then you work out the oxidation numbers. If you don't know how to do that, this video can help. I'm going to do this fairly quickly. So platinum is going to be 0, hydrogen plus 1, chloride minus 1, plus 1 again, oxygen minus 2, therefore nitrogen plus 5. Then hydrogen plus 1, chloride minus 1, therefore platinum plus 4. And then you have oxygen minus 2, so nitrogen plus 4. Brilliant. So from here, we can clearly see that platinum has gone from 0 all the way up to plus 4. So that means oxidation. And then equally, we can see that nitrogen has gone from plus 5 all the way down to plus 4. And therefore, that is reduction. Perfect. So now let's try to do question two. Part 2 is really interesting. You can try to balance this equation, and you will try, and it will not work. And the main idea of this video is, if you have to balance a redox equation, don't try the normal way. Please don't. You have to use a method. The method is in this video. I'm going to go through it today, of course, but in this video it's in more detail. So what you do is, you do 1/2 equation for the oxidation. So that would be platinum. Platinum becoming H2 PtCl6. Perfect. So first thing you do is to check that platinum is balanced, and it is balanced. So then you check the hydrogens, which are not balanced. You have 2 here. So then you balance them by adding protons. But then the next one is quite tricky. You have chlorides. How do you balance the chlorines? Well, you could do 2 things. You could add maybe, you could add 6 HCl, because we know that we have HCl. And that means you need to add protons to the other side. Or what would be more simple, you can just add chloride ion, 6. Any questions are welcome in the comments. So now what you do is to balance the charges. On the left-hand side, what we have is -1 times 6, minus 6. Platinum is 0, +1 times 2, +2. So if you put them together, that's -6 plus 0 plus 2 minus 4. And in the product is neutral, so the charge is 0. What we have to do is to add electrons to the most positive side, which is this one. And we are going to add 4 electrons to get the charge is balanced. This half equation is done. We are going to do the other half equation, which is nitric acid becoming nitrogen dioxide. First thing to do is to check the nitrogen, which is balanced. Then the oxygen. You have 3 here and 2 there. Therefore, you add 1 mole of water. Now the oxygens are balanced, then the hydrogens, you have 2 here, only 1 there, so you add 1 proton. And then finally you do the charges. The charge on this side is +1, on this side is 0. So you need 1 electron here, and that's done. Great. Next step is to make sure that you have the same number of electrons on both sides. So you need to multiply this equation by 4. And everything is going to become 4. 4, 4, there we go. Great. Next thing to do is we are going to add up these 2 half equations. we are going to, so we have added all the reactants. You see all the reactants here are there, plus these reactants, which are here. And also we have added up all the products. So these are here and these are here. And what you have to do now is to do a bit of tidying up. So the electrons cancel out, and they always have to cancel out. If they don't, there's something wrong. These 2 protons and 4 protons, we are not going to write it that way. We are going to write it as 6 protons, right? That's it. That's your answer. What you could do is, if you wanted to, you don't have to, but instead of writing 6 chlorides and 6 protons, you could have written 6 HCl. This topic and this question is very challenging. I'm going to give you more so that you can practice them. Don't get demoralized if you find them very tricky, because they are meant to be tricky, but the key thing is to use the method. If you realize you have a redox reaction at hand, use this method. Otherwise, it's nearly impossible. Perfect. So I'll let you go, and I'll see you when I see you. Bye-bye.